Firstly, we need to give the title of this lesson, Control System Theory. In the previous week we have talked about the syllabus of this lesson, and so in this lesson we'll firstly to give some introduction about the control system theory. Okay, sound is okay right now? Can you hear me? Right? Okay. And so section 1, firstly we need to debate as to what is mechatronic. Okay. To say that we can define the mechatronic I'm sorry. Mechatronic means that it's a combination of the electric plus mechanic. Okay, this is the basic term, but as an engineer we need to utilize some mathematical rules in order to build this system, as we call the dynamic system. Okay, what's the dynamic? Dynamic means that the whole we can do is the time response. Okay, if we have any integrator or the derivative term, and so we should obey the rules of the time, especially for the mechatronic system, because in simple mechanical system such as the road design or the statics or the strength of material, we analyze the statics or the constant time variable of the systems. Okay, you have one force and one body, and you apply this force, but nobody moves in that system. Okay, but in mechatronic we always constantly utilize the process some movable objects. Okay. So if we have any knowledge about the electric and mechanic, we should utilize the math to build this system in the theory, because if we have any such kind of information about the mathematical rules of the universe, and so we can easily define the dynamic system and as well as the mechatronic system. Okay, in simply the mechatronic is a combination of the electric and mechanic, but it's not, because we are engineers and we should model everything that's given in the universe to in terms of the mathematical rules or the theory. Okay, and we should always utilize the math to build this system, because we want to control this system, or we want to analyze, or we want to understand this system in order to in order to get the time response or the dynamicity or the output response of these systems. Okay, and so this definition comes with two basic definition, like this one. We need to combine this system, these two signs, with with mathematical rules. Okay, which we call it the system dynamic. Right? You have taken this lesson in order to build your system in terms of the Kirchhoff law, or electrical law, or mechanical law, or the electronical law, or electromagnetic law. Okay, but we need to interact this system in one basic domain, and so we need to give the interaction rules about science or the system in one platform, right? Which is called system dynamics. But in generally, if we talk about the mechatronic, we need to talk about the system dynamics. Okay? This is the basis of everything that we need to build the systems. Okay? This is the basic definition of these terms. But what's the system dynamics? Another question is that. The second question comes with the what? Section 2. What is system dynamic? Okay? Just remember that the system dynamic collects all the parts or the disciplines into one form. It's a mathematical form. Just like this one. For example, the mechanic. Maybe the Newton law, right? F equal m times x dot dot, right? Or we can use the what? The electrical system in this domain. Voltage is equal to the what? The I times R, or the Kirchhoff law governs the whole the equations by using these terms. Okay? Or we can add the heat theory, right? Just like the Newton describes the what? The atomic particle energy, which we call it right now the kinetic energy, by using these terms. And also we can add the what? The fluid system in here, like the Bernoulli, right? You just remember that we have some basic rules to convert the potential energy to kinetic one, and so this whole terms combines or creates the what? The total system dynamic equation based on the what? The mathematical formulation. Okay? And so how can we obtain this system? Systems. Using the math. First of all, we need to derive the what? The equation of motion. What's the equation of motion? Anyone know that? You know it? Equation of motion? Anyone? Yes, this is the governing equation or the obeying equation to the universe, just like this one. For example, if we have the any mechanic system, and so this system should be obey this one, m times x dot dot. This is a Newton law, right? Or we can say that if we have the rotational system and then we have the inertia times theta dot dot, right? This is the basic rules. Or if we have any voltage in here, like this one, the inductance values, and so this inductance creates the what? The voltage difference based on the what? The changing currents in here, right? And so this comes from to the what? The basic rules of the universe. But we should always apply the Kirchhoff law, or as we know, the conversation of mass. The total energy are always the same for this system, and then we will get the what? The dynamic equation, which is applied to the what? The Kirchhoff law or conversion of the conversation of the mass rules in here. Okay? And if we have a system, this system kept its energy always to what? The same at any time. But this system has a velocity, or some changing parts maybe happen in this system, and which we call it to the what? The dynamicity. Okay? Or in another term, equation of motion. Okay? So if we have this notion, and then we will always the what? The time dependency in this system. Okay? What's the time dependency? We have the time response. just like this one. Or we can say that f is the function of the time. Okay? At every system in mechatronic designs, we will utilize or deal with this definition. Okay? And so just remember that we have two tools to analyze this system in system dynamics. The former one is the what? Transfer function, right? The another is state space, right? One of them is based on the frequency response, and the other term is the time domain, right? And so if we have this system, or either if we are using the transfer function, we can describe the whole system like this one, GS, right? Or if you want to use the state space domain, and then we will write to the x dot is equal to the ax plus b times u, right? Just see that in system dynamic lesson we have created the whole system based on this information. And then if we have this information, and then we can drive the system to anywhere, because if we have this information, and so at each state or each particle or each space, for example position, velocity, or another else, can be obtained using this equation, and so we can drive the system to any point by using these equations. Okay, this is so important, because if your real system should be matched with with this dynamicity or the transfer function or the state space, and then we can control this system based on these informations. Okay, any question? Okay, and so another problem is that another question comes with the what is control, but not in matrix form. Okay, the control theory. So suppose that we have a system like, for example, if we have any actuator design in here like this one, this is the actuator of this system, and so we attach the mass parameter in here, and we can define the x variable for the changing the position values, and so we want to move m to the 10 centimeters or 0.1 meter to the right hand side. Okay, this is the basic problem to achieve to control this system. Okay, and so in normal case we have this information in here like this one. For example, if we want to utilize the transfer function domain, we should obtain the GS, plant S formation, and so this generates to the in this case, what's the name of this output value in here? Position, right? Position XS, because we want to control these terms in here, and so we need to set this transfer function to produce the disposition values, right? But we also need to provide some information or the inputs to move the XS to the 0.1 meter, right? And so if we have this information, and so this is the US. What is the US value in here? No, this is the input value, but what's the type of this US? For example, XS is the what is in terms of the position values. It represents the position, but the US, what is the type of the US in here? Force, right? Because if this has a mechanical system like this one, we need to give the what to this system, to this system, to the what, the force value, right? This must be force. And so, but we have the some trajectory in here, or the reference points, and we have only know to what the 0.1 or 0.2 or the x reference value in here, okay? And so we should define the x ref as in here, like this one, right? Because we know that in here. For example, if you are using the what, the user interface, and so you need to provide the this value, and the system must goes to the what, to this one, right? And so how can we condition this system based on this information? Firstly, we need to add the some another part to this block diagram, right? Because the GS is constant, right? We cannot control it right now. But if we are using or defining the some new blocks in here, like this one, and we generate this force value based on this information, because this x ref should be given in here, and then we can manipulate or drive the system to the what, to the specific points, right? But if we have only utilized the what, the GS, we cannot condition this system because it still remains the same all the time, right? We cannot change it. But if we add another block or another part, which we don't know right now, and we can condition this system, right? And so, which is named with the what, the controller. And it's based on the what, the mathematical rules of the what, the system dynamics. And it states, in a conclusion, we need to say that if we have a plant in here with the what, with the reference signal, position, velocity, voltage value, and etc., and then we can design or we can manipulate this system by adding the some another block based on the what, the S domain or the transfer function, or in a simply mathematical formations, right? Do you understand what I'm saying in here? Any question? Okay. And so, if this is the case, we should utilize the what, the math, right? And so, what is the transfer function of this system? First, we know that if we have the force value, which is coming from the what, the actuator, and then we should transfer this energy into the what, the mass. And so this creates to the what, the acceleration on these systems, okay? And so all the energy preserves by using what? By using this equation. This is the Newton law, right? And then how can we obtain the transfer function of this system? Just remember that if we have the time dependent signals in here, which is the what, the f and xt, in terms of the, it's depending on the time, and so we can write easily right now fs is equal to the m is a constant and it remains the same, and xs times with what, s square, right? And so we have the us in here, and xs or us is simply fs, right? And so if we have this information, xs fs is equals to what, the 1 divided by m times square, s square, right? This is what? This is the plant equation of this system, okay? This is our model. And so if we have this information, I redesign these buildings, m times s square, right? And this generates the what, the xs, right? the position values in the water frequency domain. So we have also Fs in here, and also we have the CS block, and this CS should be provided with the water X reference values, right? So how can I drive the system to this position based on these informations? We have the mathematical implementation of these terms, especially with the water frequency domain approach. And so how can I equalize this system in order to control this system? So we have the one condition is that xref s must be equal to the xs, right? This must be satisfied. Otherwise we cannot control the system, right? It's the basic rule. To equalize the whole this two xref and xs value to the what at the steady state, or the at the infinity time, which is equals to the 0, which is equals to the another one, right? And so if we have this information in here, and then xref times c times 1 divided by m s square must be equal to what? The x, right? And so we know that this condition, and so this term must be what? Must be equal to the what? 1. But why? Yes, this denominator should be removed by the what? The c, because we can change the c or update the c or select the c by using the what? The sum control theory perspective or the system dynamics perspective. And so c times 1 divided by m s square must be equal to the 1. And so cs must be equal to the what? M s square, right? This is what? This is known as controller. Right? Do you get it? The notion? How can we manipulate the system by using or selecting some basic rules in the what? In the control theory. This is the basics of the control theory. If we have a reference signal, we must provide or we must equalize this system with what? The output response in terms of the what? The transfer function domain or the state space domain. And then if we want to do that, we need to provide some mathematical based rules to this system, which is called to the what? Controller, right? Okay. This is the controller. But this controller is also known as open loop controller. Why? Yes, we don't have any feedbacks in here, okay? And so how can we add the feedbacks to this system? This is the open loop controller, right? But why we need feedback in this system? Yes, we have no ideal system, okay? In real life everything is non-linear, and so we have made the what? The friction or the some losses function in the real life application, and so we need to measure or take a feedback from the what? From the sensors in order to what? In order to control at any time to what? Our mass is goes to 0.1 or not, right? Because we cannot know that, right? And so, in this domain, we need to draw the system based on this information. We have the plant in here, like this one, and so this plant generates the what? The XS. Okay? And so, if we want to measure this information, and then we can utilize to what? In real life application, what's the name of these terms to measure these things? Huh? HS, but it's the represented name. This is the sensor, right? And so this sensor must be provided to the what? The some other blocks in here, because if we have this sensor and if we have also the X reference value in here in S domain, and so we need to drive the new variable in here, right? Which is called, yes, ES, error. And so this error should be provided to the what? The some another block in here. This is the controller, right? CS, we can design it, but this CS must be what? Drive the actuator, AS, right? And so this actuator generates to the what? The force, right? In real life application, that is the case, okay? And so this is XS, and so what's the type of this signal in here? Huh? At this one, between the AS and the plant GS. This is equal to the what? The FS, right? And so actuator must be driven by the what? The controller. And so what is the input of the actuator in real life? Volt or current, right? And so what is the CS? Controller, but in real life, electrical circuit, right? And so this is known as the closed loop design or system. Okay? Any question? If we have this system, and then if we have designed the proper controller in here, and so our reference maybe 0.1, and so the R system may have this kind of time response, but at t it goes to infinity, and then we will have the what? The zero error values, right? Et must goes to 0 when the what? T goes to infinity. And so the controller design must provide this condition, okay? This is the second condition about the control theory, okay? The controller guarantees that this Et goes to 0 when the t goes to what? The infinity values, okay? How can we drive this Et? By using the what? The sum, taking the measurements from the what? The sensors. And also we have the reference value provided by the what? The some computer programs or the user input, okay? And the rest of them are a physical components in real life, okay? So we can also build the real representation of these terms. For example, if we have the mechanical system like this one, we have designed the actuator in here, okay? And in order to interact the actuator with the what? With the some mass, we should utilize the what? The rod right? We need to use it. And so how can we obtain the position values of this term? This is maybe infrared sensor, okay? And so we can take or generate what the xt value using the what? This infrared sensor, right? We can take it, the deflection rate of this mass in real life application. And so if we want to use this infrared sensor, and then we need to design what? The sensor board, right? And we need to fit these terms in here like this one, okay? This is the what? The analog signal, right? We can take the voltage or the current value, but in continuous domain or in analog formation. And after that, we should collect the whole the information into the one system, which is called the microcontrollers, right? And so the microcontrollers can transfer the whole the information in here by using the what? The ADC, analog to digital converter, right? Or we can transmit the whole the information by using the what? The UART, I to C, or the SPI, communication techniques, which is given in the what? In microcontroller system, or in this lesson, okay? And also, if you want to move the actuator in here, we need to what? Some electronic driver or the motor driver, right? For example, for a step motor, step driver should be used in here. Or for the DC motor, we need to build the what? The some transistor mechanism to increase or gain the voltage value or the current value based on the what? The command values coming from this microcontroller. This could be DAC or PWM, but we may also utilize the what? The UART, I to C, or SPI communication to drive these drivers, okay? So this motor driver drives to the what? The actuator, like this one, current 2 and current 1. Maybe I1 is utilized to what? To rotate the right hand side to the motor, or I2 is used to what? To rotate the left hand side, or left rotation, to provide this actuator, okay? So this motor driver is given in here, and then we need also to what? We have a power supplier in here, right? This should be fed with what? 220 volt with an AC, and then maybe in your case the motor driver should be fed with what? 24 volts, okay? And microcontroller maybe 3.3 volt or 5 volt, which is the type of the microcontroller are depends to the what? To demand voltage values of these terms, or this sensor board should be fed with what? Minus 10 to 10 volt or 5 volt, okay? This entirely depends on the what kind of sensor should be utilized or are utilized in your system, okay? And also we need to maybe feed the actuator, for example 48 volts, okay? So This is the real representation of the R system, but as an engineer, we will deal with what also theoretical calculations based on what the system dynamics and another theory. Okay, and so firstly, as an engineer, we utilize the system dynamics and control theory to the theoretical calculations, right? And so these theoretical calculations should be simulated with the MATLAB or the Python softwares, right? Python. And after that, we should create the embedded code design in here. Because this MATLAB and Python doesn't provide the embedded code to be utilized in the microcontroller structures, right? And so if you have a MATLAB model or simulation model, you need to convert this information or the models to the embedded code to drive this system. Okay? And so this embedded code creates the total software code. But this software code have both the user interface and the embedded code. Okay? And after that, we need to upload the codes into the microcontrollers. Okay? This is the real representation of any control system. Okay? And so we can add the control system. Okay? Any question? Do you understand what I'm saying in here? Because it's important, and so you need to always build this diagram for your projects, and after that you should put some information or the theory to this diagram, because it's the basic sketch for your control applications. Okay? At the beginning of your projects, you must define these conditions to create a systematic solutions for your systems. Okay? After that, you need to fill every part of these terms. For example, you want to select the actuator for for example, between the 0 to 10 Newton times meter, or the torque values, or you need to select the motor driver to 0 to 10 ampere. Okay? Or you need to define your system based on microcontrol is the 72 megahertz. Or you can select, or you must select we need to use the 3 UART to SPI must be provided in here with the 12 ADC signal. Okay? This is the basis of of your control system applications. Okay? Any question? You have get everything what I'm saying in here? Can I believe that? Okay. So we have taken the many lessons in mechatronic engineering, but how can you utilize this lesson to build the control system based on the system dynamics? Main problem is right now. Okay, how can I utilize the other lesson we have taken to build control system. Okay. Firstly, we need to understand that for equation of motion, we should utilize the system dynamics course. Okay. But what is system dynamics? Firstly, you can use the dynamic course lesson or the information, right? If you don't have any information about the Newton's law, and you cannot create a mechanics dynamics, right? Or you should use the electrical lesson. For example, the analog electronics. Am I right? That's that. So analog electronics gives you a basic information about the Kirchhoff law. Okay, or this is the F equals ma, right? Or statics should be learned from the rod design. Just remember that if you have the weakened rod in here with the basic dimensions, and then this rod may be broken in real-time application, right? And so the statics helps you to design your system to build the stable system, right? And to define the electronic board design, which includes the sensor board, right? And control panel. And so the analog electronic information, the analog circuit information should be known, right? Or electronic or electrical theory lesson, right? And then if you have the rules of the analog circuit, and then you can design the control panels or the sensor board, right? Or for actuator design, you need to build the motor driver, and the selection of the actuator must be given in here. But how can you do that if you have taken the electric theory lesson, and then you can easily select the motor driver? For example, if you have the step motor, and then you can select the proper step motor and also its driver based on the information of the electromechanical energy conversion lessons. Okay. Or if we select the motor design, and so the robot dynamics or the kinematics must be utilized to select the proper motor values in terms of the force or torque value, right? If you require the 10 Newton meter motor, and then you should provide this feature by using selecting the proper motor values. Okay. And for driving the system, you need to learn about the microcontroller programming, right? Or generate the reference signal. You must know the signal and systems lesson, right? Or Python, or the object-oriented programming to generate this signal, right? And so this whole things creates the mechatronic design based on this scheme, right? If you want to create or build the mechatronic system, you must know about every lesson, right? And then we can create the system dynamic equation, and also we will design the controller in here. And in order to implement this information in real-life application, you must know about these 5 things in here. Okay? This generate reference is an important thing in control system because, for example, if we have the signal, position signal with the 1 meter or the 1.2 meter, or we have a reference signal just like this one, xref 5 times sinus 2 pi 1 dot t. Okay, and so if you want to condition this system 5 dot sinus, and you must know about the signal and system lesson course information, for example the frequency domain approach or Fourier transform, or you may have the neural network structure to build your reference, because in autonomous drive or the robot system we want to use the camera to detect the objects, and so this reference signal is generated by the artificial neural network with with detecting the objects, and you can have the x and y coordinates, and you can pointing your device to this one. Okay, the generating reference is directly related to the signal and system lesson or another lesson, just like the neural network or the computer vision lesson. Okay, but you must convert all the things into the understandable form for the microcontroller process. Okay, otherwise you cannot drive the system to this point, right? Any question? Okay, let's take a break, and after that we will provide the analogy model in mechatronic engineering. Okay.